Okay, in this section, section 5.5, we're going to solve two types of equations, exponential equations and log equations. So the first type of equation, sort of the general form, see what does it look like? Maybe something along these lines, like a to the x is equal to, now how do we want to write this? Let's just do it by examples. So, for example, number 1, we want to solve this equation. 3 to the x is equal to 81. And so the steps that we want to do here is we look at, and so in this particular problem, there's only one x value in the exponent. There might be another problem where we solve something kind of like 3 to the x is equal to 2 to the x plus 3 or something, and here we have an x value in two different exponents. In this problem, we only have an x value in one of the exponents. So when that's the situation, what we do is we look at what's the base of that exponent. In this situation, the base is 3. And we're going to take the log of that base on both sides. So our first step is going to be to take log base 3 of the left, and then log base 3 of the right-hand side. So now we can use log rules. Well, this x is an exponent, so now we can put that into the front. So the next line, what we can write is this. And also, 1 second, I need to get a calculator. We can rewrite 81 as sorry, 1 second. 3 to the 4th power. So what we could do is this is going to be log base 3. And then 81 is just the same thing as 3 to the 4th power. Then on the left-hand side, we have log base 3 of 3. And we always said whenever the base and the inside are the same thing, that's just equal to 1. So the left-hand side is just going to be equal to x. And the right-hand side, now we can bring this 4 and move it into the front. So let's see, 4. Now we can write this as 4 log base 3 of 3. But now we have log base 3 of 3 on the right-hand side. Again, that's just 1. So what we see is that just x is equal to 4. All right. Let's do some more of those. Number 8. So number 8 says 4 to the 3x minus 5 is equal to 16. So now the thing that has the exponent is this 4 to the 3x minus 5. So what we're going to do is take log base 4 of both sides. So we'll do log base 4 of the left-hand side, and then log base 4 of the right-hand side. So on the left-hand side, that power of 3x minus 5 can be written in the front. And we're left with log base 4 of 4. And on the right, we can rewrite this as log base 4 of 4 squared, since 16 is the same thing as 4 squared. So on the left-hand side, log base 4 of 4, that's just equal to 1. So we have 3x minus 5. And on the right-hand side, that 2 is going to go in the front, and we're just going to be left with a log base 4 of 4, which is 1. So really, the right-hand side is just 2. And now to solve for x, we just add the 5 over, and then divide by the 3. So x is equal to 7 over 3. Can do 15. So 15 says e to the minus c is equal to 5, 2 to the c. So in this problem, we have two things that have the exponent. So in this situation, we can say we're solving for c. Not slow solve. So in this situation, so before, like, you can just look up in problem number 8, how we had 4 to the 3x minus 5 is equal to 16. Only one thing had the exponent. Down here, two things have the exponent. And when that's the situation, it doesn't matter which base we choose. So let's just choose the e as our base. So we're going to take the log base e of both sides. So log base e of the left-hand side, and then log base e of the right-hand side. So now we can still use our log rules. So on the left-hand side, we have a power of a minus c. So minus c is going to go into the front. And we have log base e of e. On the right-hand side, the power is 2c. So 2c is going to go into the front. And we have log base e of 5. So on the left-hand side, we have minus c, log base e of e. Log base e of e, that's 1 because the base and the inside are the same thing. So we just have minus c is equal to 2c log base e of 5. And then what we can do here is, so we need to solve for c. So what we can do is let's add this c onto the from the left-hand side over to the right-hand side. We can't really simplify this log base e of 5. We're just going to leave it the same right now. So if we add that other c over, we're going to get 0 is equal to c plus 2c log base e of 5. And so then what we can do now is we could factor out that c. Then we're going to have 1 plus 2 log base e of 5. And so now what we can do is we could take that 1 plus 2 log base e of 5 and divide it over onto both sides so we can get c alone. So let's do that. Divide by log, or 1 plus 2 log base e of 5. So on the left-hand side, we just get 0 divided by that number, so it's 0. On the right-hand side, we just get c. So we see that our only solution for this problem is going to be c is equal to 0. All right. Let's do 21. So this is 3 to the x is equal to 2 to the x minus 1. So here what we could do, again, we have two exponents, so we can just choose whatever base. Let's use the right-hand side, log base 2. So let's take the log base 2 of the left-hand side. And let's take log base 2 of the right-hand side. So the left-hand side, just by doing the same steps that we've been doing, the x is going to move into the front, and we're going to have log base 2 of 3. On the right-hand side, that x minus 1 is going to go into the front. And then we would have log base 2 of 2, which is just equal to 1. So we don't really need to write that. We just need to write the x minus 1. And so just like before, what we could do is, we need to get, so we're solving for x. So we need to get x on the same side and everything else on the other side. So let's take this x and subtract it over to the left-hand side. So we would have x log base 2 of 3 minus x is equal to minus 1. Then what we could do is we could factor out the x. And after we factor out the x, we can just divide this piece over to the right-hand side. So we get x is equal to minus 1 divided by log base 2 of 3 minus 1. Okay. Let me see, where's the homework sheet? Okay. So that kind of takes care of all the homework questions for exponential equation. Now let's just talk about log equations. So for example, let's solve something like 32. So what we want to solve here is log base 2 of x is equal to minus 3. So whenever we're doing these problems, we want to use this property, the property that a to the log base a of x is equal to x, where this is the power of a. So what we're going to do here is we look at this equation, log base 2 of x is equal to minus 3. What we do is we look at our log and we see what our base is. Our base is 2. And then we're going to take 2 and then raise it to both sides of the equal sign. So what we mean by that is what we're going to write now is going to say is 2 to the left-hand side. So 2 to the log base 2 of x, and on the right-hand side, 2 to the minus 3. So we're taking 2 to this power and equaling it to 2 to this power. And now using that property of the logs that we have over here, the left-hand side really is just x. And the right-hand side, 2 to the minus 3, that's just the same thing as 1 divided by 8. So for this problem, this is what we get as our answer. X is equal to 1 over 8. So 39 says log base 2 of 10 plus 3x is equal to 5. So now the base of our log again is 2. So what we're going to do is we're going to take that number 2. So we're going to do 2 to the left-hand side. And then we're going to take 2 to the right-hand side. So the left-hand side just simplifies to the inside of the log. So 2 to the log base 2, they just cancel each other out. And the left-hand side just becomes 10 plus 3x. Again, that's using this property up here. And 2 to the 5 might be 32. I don't know. 2 to the 5 is, 32. So then just solving for x, we can subtract the 10. So we get 3x is equal to 22. We can divide by the 3. X is equal to 22 divided by 3. Another thing too that we need to mention, it wasn't too important for these two problems, is that when we get these answers, we need to make sure that if we plug it in, this I guess isn't something, I'm actually surprised this wasn't a question on any of in the book, I don't think. Something that we need to make sure about the log equation, let's actually just talk about that right now. The domain of log of x. So for any base, doesn't matter what it is. So if we have f of x is equal to log base a of x, the domain is x is strictly bigger than 0. And really what that means is whatever is on the inside of our log in the situation x, that piece needs to be bigger than or equal to 0. So for example, let's find the domain of f of x is equal to log base 11 of 3 minus x over 2. So we're looking above, the domain of our log is just whatever's on the inside needs to be bigger than or equal to 0. Sorry, not bigger, it has to be strictly bigger than 0. See, bigger than 0, not bigger than or equal to. So in this situation, 3 minus x over 2, that's what's on the inside of our log. So what we need in this problem is we need 3 minus x over 2 to be strictly bigger than 0. So if we solve for x, we can add the x over 2 over. So we need 3 to be strictly bigger than x over 2. Multiply the 2 over. We're going to get 6 has to be bigger than x. So our domain on the number line, here's 6. We have an open circle on it because it's just a strict inequality sign, and x is going to be less than it. So our domain here would be minus infinity all the way up to 6. So the thing that we need to keep in mind is that everything that we plug inside of a log, so all these values that go in, they have to be positive numbers and they can't be 0. It has to be a number bigger than 0. So when we find these answers, like for this one right here, we need to look if we plug it back in here. All we care about is if the number is positive. But if you see, if we plug in 22 over 3 and for x, this inside piece is going to be a positive number. So that's going to be okay. But we'll do some problems in a second where we do all this work and we get an answer that if we plug back inside in this section, we actually get a negative number, and then we just have to get rid of that answer. Let's do 41 maybe like that. Let's see. So for 41, what we have is log of x plus log of x minus 9 is equal to 1. So for this problem, before, you see what we did is we only had one log on the one side and a number on the other side. And we still need that, but in this problem, we have two logs together. So you see the problem before that we did, there's just one log and then one number. And we need that setup. That's how we do these problems. But now we have two logs, but we know how to add, we can combine these logs together. Whenever doing one log plus another log, we can write one log and just multiply the insides. Remember, we have this formula, log base a of x plus log base a of y is equal to log base a of x times y. So if we do that, we get, there's these two logs, but they're adding together. So we can actually just write that as one log symbol. So one log, and then we'll do x times x minus 9. And that's just equal to 1. And remember too, when we don't write the base, we don't have a base written here. That means the base is 10. So what we're going to do now is we're going to take 10 to the left-hand side is equal to 10 to the right-hand side, which is the same step as what we did in the previous problem. So we're going to do 10 x minus 9 is equal to 10 to the 1. So now on the left-hand side, that 10, the log 10, remember this is a log base 10. So that 10 and the log are going to cancel. So all we have on the left-hand side is x times x minus 9. And on the right-hand side, we have 10 to the 1, which is just 10. So now we need to solve this equation. If we distribute the x, we're going to get x squared minus 9x is equal to 10. Then we're going to subtract that 10 over. So we get x squared minus 9x minus 10 is equal to 0. And we're going to factor. We're going to get x minus 10. X plus 1 is equal to 0. And then this tells us that we get two answers. X is equal to 10. X is equal to minus 1. So we have these two answers. But we need to make sure that if we plug either of these answers into the x values up here, we do not get negatives on the inside of the log. However, so if we plug in 10, we're okay. So you see, if we plug in 10 here, we'll get log of 10, so the inside's positive. And if we plug in 10 right here, there's 10 minus 9, which is 1. That's still positive, so that's okay. However, notice that if we plug in minus 1, we get log of minus 1. And we can't do that. The inside always has to be bigger than 0. So we have to get rid of this answer of minus 1, because if we plug it in, well, we can't plug in x equals minus 1 because we'd have log of minus 1, which we can't have. It has to always be bigger than 0. So our only answer for this problem is going to be x is equal to 10. Let's do 44. So this is log of x plus 5 plus log of x, or wait, 45. Which one are we doing? 44. Log of x plus 5 minus log of x minus 3 is equal to log of 2. Okay, So now what we need to do, so we need to combine the logs on the left-hand side together. So we can combine the subtraction with division. So we can rewrite the left-hand side as log of x plus 5 divided by x minus 3. And that's just going to be equal to log of 2. So remember, we have this property that log of any base x minus log, doesn't matter the base, y, this is going to equal log of that base, x over y. So that's the property that we just used. So now what we have here is, so remember these are log base 10s. So what we can do is take the 10 to both sides. So we can get 10 to the left-hand side. And then 10 to the right-hand side. Oh, sorry, log base. Log of 2. So we have 10. So remember, these are log base 10s, which we don't need to write the base 10 because that's just sort of like assumed when we don't write the base. So on the left-hand side, that 10 and the log cancel. So we just have x plus 5 over x minus 3. And on the right, the same thing happens. The 10 and the log cancels. We just have 2. Again, remember, we have this property that this is the property that we're using. A to the log base A of x is just equal to x. And this x is a placeholder, so meaning anything on the inside of the log, all it does is it just goes right here. Okay, now to solve this equation, we need to multiply that x minus 3 over to the right. So we're going to have x plus 5 is equal to 2 times x minus 3. So then we have x plus 5, distribute the 2. Now subtract this x on the left over to the right. So we're going to have 5 is equal to x minus 6. And then add the 6 over to the left. 11 is equal to x. And remember, we need to check. If we plug this x equals 11 into here or here, do we get any negative numbers? In the first one, no. We'd get x plus, see, we have an x plus a 5. So if we plug in 11, that's positive. And here we have x minus 3. If we plug in 11, that's still going to be a positive number. So x equals 11 is okay. Let's do 55. So 55 says natural log of x plus 8 plus natural log of x minus 1 is equal to 2 log of x, or natural log of x. So we need to, let's combine everything on the left-hand side. So we're adding 2 logs. So what we can write this as is natural log x plus 8, x minus 1. And on the right-hand side, we can bring that 2 on the inside as a power. So natural log of x squared. Now what we want to do is we want to get rid of these natural logs. So remember, natural log means log base e. So what we're going to do is we're going to do e natural log of x plus 8, x minus 1 is equal to e natural log of x squared. So now the e's and the natural logs cancel out. So what we have is x plus 8, x minus 1 is equal to x squared. So let's distribute on the left-hand side. So we're going to get x squared minus an x plus an 8x minus an 8 is equal to x squared. So that's just by FOILing out. Let's see, we had, yeah, minus x plus 8x minus 8. Okay, so then on the left-hand side, we get x squared plus 7x minus 8 is equal to x squared. So we can subtract the x squared over to the left, so those just cancel out. So what we have is 7x minus 8 is equal to 0. And we can add the 8 over. So 7x is equal to 8. We can divide by the 7. X is equal to 8 over 7. So again, you need to plug this in here, here, and here, and make sure we don't get a negative number. However, if you plug in 8 over 7, this number will be positive, this number would be positive, And that number would also be positive, so we're okay. So x equals 8/7 is going to be our answer. All right, so that takes care of that section. Let's do the last one, section 5.6. So there's not many questions, just basically one main question from this section. Let's see what's the So this whole question, this section is about this formula. We have P of t is equal to P naught times e to the kt. And this formula is called like the exponential growth formula. And so these variables above, first, so what does P of t mean? So P of t is going to give it like, so we're talking about, what's happening here? All right, hopefully everything's still good. So P of t, this is gonna, so we're talking about exponential growth. So when we mean growth, maybe like a growth of like a bacteria or something, or the growth of the population. So when we're talking about P of t, this is going to be the size of the population at time t. And then P naught is going to be the initial size of the population. K is called the growth constant. And T is just time. So sort of like a standard example is, let's say, suppose a population has a growth constant or has a exponential growth constant of 2%. Say, suppose the initial population is 2 million. So let's do a couple of things. Let's find the equation for P of t. Let's estimate the population after 10 years. And C, find the time it takes for the population to double. All right, so the first one. So we need to find the equation. So remember, the equation is this. P of t is equal to P naught e to the k times t. So we're trying to find the equation for P of t. So we need these variables right here. So P naught is given to us in this problem. It says the initial population is 2 million. The growth constant was also given to us as 2%, which means 0.02. So our formula is going to be, so for part A, is just P of t, so it's equal to P naught, which is just 2, and then e to the k, which is 0.02 times t. So then this is going to be our formula for P of t. So now estimate the population after 10 years. So that just means P of 10. We want to plug in 10, we want 10 years, so we're going to have T be 10. So this is just going to equal 2 e to the 0.02 times 10, which is equal to, let's see a sec, e to the 2 times 2, which is 2.44 million. And the third part, how long does it take for the population to double? Well, our initial population, so let's think about that. We want to know how long does it take for the population to double? So we want to find the t value such that the population at that time value is equal to 4. Right? Because we want to know when's the population going to double. So when is our initial population is 2 million. So when is it going to double to 4 million? So we just need to solve this equation, P of t is equal to 4. But we know P of t is equal to this. So the equation that we want to solve is, well, we want P of t is equal to 4, but we know P of t is the same thing as this. So that's just the same thing as solving 2 e to the 0.02 t is equal to 4. So we need to solve this exponential equation now. So what we do is we divide the 2 over. So we're going to get e to the 0.02 t is equal to 2. Then now what we need to do is, well, we have an exponential equation. Our base is e, so we need to take the log base e of both sides. So log base e of the left-hand side. So this is just like the problems that we did in section 5.5. And then log base e of the right-hand side. On the left-hand side, that log base, so the power goes into the front, 0.02 t. And now we're left with just log base e of e, which is 1, so we don't need to write it. And so that's just going to equal over here. We have log base e of 2. Remember, that's just the same, this is right, that's the same thing as natural log of 2. Natural log, let's put that into a box up here just to remind everybody. So natural log, that just means the same thing as log base e. Okay, so what we have is 0.02 t is equal to the natural log of 2. So we divide by 0.02. So t is equal to natural log of 2 divided by 0.02, which is equal to 34.66. So that's how many years it would take for the population to double, is 34.66 years. Okay. Let's do a problem similar to 11. So let's just make up a table. So we have our substance, then the decay rate, and then let's say half-life. Let's do, let's see, oh, okay, that's fine. Let's just do 2 substances. We have substance A. We got substance B. So let's say our decay rate for A, we don't know. And then the half-life is, let's say, 20 years. And let's say the decay rate for B is, let's do -7%. And we don't know the half-life. Now let's say we want to fill out this table. So fill out, or maybe complete the table. So let's first talk about substance A. In general, I guess before we do that, remember we just have that same equation. P of t is equal to P naught e to the kt. So for substance A, what do we know? Well, so half-life. So we got to think, well, what does half-life mean? Well, half-life, that just means the amount of time it takes for your initial substance to cut into half. So let's say if we have P naught as our initial substance, well, after the half-life, so after this amount of time, we're only going to have half of our initial substance left over. So let's call this T, maybe how do we want to say this? So this is a specific T value. So that means that after that specific time value, we have half of our initial substance left over. So in this problem, we're given, or let's start the problem down here. This is just sort of like a general thing. So in problem for substance A, we're given that our half-life is equal to 20 years. So what this tells us is that P of 20, so after 20 years, we're only going to have half of what we started with. And so we're looking for our K rate. So what is K? But we actually know enough now to solve for K. So we know P of 20, the time, so after 20 years, we only have half of what we started with. Well, we also know we can find P of 20. P of 20, that's equal to P naught e to the 20K. All we're doing is we're plugging in 20 for T up here. So then what we can do is, well, if P of 20 is equal to 1/2 P naught, well, that's the same thing. So P of 20 is also the same thing as P naught e to the 20K. So what we have is P naught e to the 20K is equal to 1/2 P naught. You see, we have P of 20 here, P of 20 here. That one's equal to this. It's also equal to that. So all we're doing is just setting those things equal to one another. Now notice that if we can just divide P naught onto both sides. So they cancel. So we have e to the 20K is equal to 1/2. And now we know we can solve this equation just by taking the natural log of both sides. So take the natural log of the left-hand side, natural log of the right-hand side. So the left-hand side just becomes 20K, natural log of e, which is just 1. And then the right-hand side just stays the same as natural log of 1/2. And so what we get is K is equal to natural log of 1/2 divided by 20. So then we found that we filled out this section of the table. We found that that piece, our decay rate is going to be natural log of 1/2 divided by 20. Now for substance B, what are we given? Well, we're given that our decay rate is minus 7%. So we're given that the decay rate is equal to minus 0.07. And we want to find the half-life. Half-life T. We don't know what T is, but we do know that P of T of that time value has to equal half-life. So after that amount of time, we need half of what we started with. So we know P of T is also equal to P naught e to the kt, but we know that K is equal to minus 0.07. So this is actually equal to P naught e to the minus 0.07 T. So we know that P of T is equal to 1/2 P naught, and P of T is also equal to P naught e to the minus 0.07 T. So we get to set those two things equal to each other. In doing that, what we're going to get is 1/2 P naught is equal to P naught e to the minus 0.07 T. So just like before, we could divide by P naught and we're going to get 1/2 is equal to e to the minus 0.07 t. Take the natural log of both sides. So the left-hand side stays the same, natural log of 1/2. The right-hand side simplifies into minus 0.07 times t. And then what we can see is t is just equal to natural log of 1/2 divided by minus 0.07. And so that would be our half-life. So after this amount of time, which if you plugged it into a calculator, let's see, what is that? So you got natural log 1/2 divided by minus 0.07. This is equal to 9.9 years, or we didn't say give a time, just 9.9. So that's equal to t. Maybe it's years, or what did we say? Oh, let's just make it minutes. Let's say 9.9 minutes. Okay. So that's good from this section. So basically your only homework problems are just the two that we just did together. There's a question just like this one that fill in the table, and then the question just like the first one from this section. Okay, so this is an okay place to end it for the day. So yeah, well, so thank you. I'll see you guys tomorrow for the next video.